I quite like air fresheners, but not all the time. I know these things are mostly sold for people who want to mask an aroma in their house, and to be honest, I don't really have many aromas in my house that I know of, but I quite like a little burst of aroma every so often just because it's quite nice. Stimulates the senses. And unfortunately, air fresheners fall into two categories. The ones that take the big tins and they just pump it out 24/7. Really, their whole goal seems to be to empty the tins so you have to buy a new one. And then the other ones that just fire it out when they detect movement in the vicinity. And they use a very simple mechanism for detecting movement. It's simply a light sensor. And they take the much smaller tins of the aroma chemicals, which strangely enough cost pretty much the same as the big ones. And they work on the basis that it's a really concentrated aroma and it's not being squirted out very often, so it should last a long time. And the downside of that is that the smell of these things is usually quite repulsive. Because they've used as much concentrated aroma chemical as possible, it just seems to be simpler, aromas, and it's just unpleasant. So what I'd like to do is I'd like to use the circuitry out of this one and transplant it into a bigger air freshener so that I can use the wider variety of aromas. And I have to say my favourite aroma these days is Airwick Anti-Tobacco. I don't even think this is a regular aroma. I found this one in BM Home stores, and it's although it says anti-tobacco, it's a really complex smell. It's lots of different layers. It's really nice. The other one I like is Dark Plum and Honey out of Poundland, which, unlike most cheap air freshener cans, like, say for instance this Air Pure Vanilla, this is just minging. This is absolutely terrible. It's like they took the one component of air freshener, they took vanilla, or the vanilla type aroma, and when it puts out, it's just nauseating. These ones at least have some depth to them. So I'd like to make that modification. And the first thing I'm going to have to do is find an air freshener that the circuit board out of that one fits into. And these ones, if I show you the inside of this one, because I've already undone the screws, it's crammed everything down into a very small area indeed. There's really not much space for circuitry in here. It might fit in, but if it doesn't, I'm going to have to open some other air fresheners and look and see what's inside them. This one is actually a very clever design because it addresses an issue that with people putting the air freshener tanks in the first place, that they sometimes don't do it correctly. And it's not actually possible to do it incorrectly with this design, because if you sit a can into the base, and it holds it quite tightly, no matter what way you put this on, because it's got this diverter, no matter what way you put it on, it not only aligns the nozzle up as you twist it so that it comes into perfect alignment, but also it pushes a little plunger back up inside if it's been left in a down position. So it's quite a clever design. However, I'm going to strip this thing apart, get the circuit board out it, see if it fits in that. If it doesn't, I'm going to open up some others and see if it fits. Now this thing, the way it detects movement is quite clever. These big ones, you can also get the passive infrared detector on them that detects movement, but unfortunately all it does is it steps up from being fairly irregular, pumping out all day, to an extra burst, and it's like, oh, that's definitely not what you want. So what this thing does, it's basically got a light sensor. Just draw it as a little sort of LED style light sensor, and if it was just looking into a room like that, and you moved across the room, it's measuring the sort of ambient light in the whole room, and your movement across the room wouldn't make much of a difference. But what it does is it puts a little tube in front of it, or a little light guide, so that all it can see now is a very narrow area ahead. Like, imagine getting a piece of pipe or a piece of the tube out of the middle of kitchen roll and just looking through it, and you'd only see a small sort of circle of, a small area of the room. Now, when that body moves into that area, it causes a sudden contrast change. It makes a strong light level change, and that's what this unit detects. It detects the sudden transition of light level. And that's the simplest possible sensor. And that means it only runs during the day because it can only see you during the day. It won't run at night unless you've got a light on the room. And it only fires when it sees a distinct change, the sort of sudden light level transition. So I'm going to start taking things apart now, and to save you the boredom of seeing me unscrew random bits, I'm just going to pause and I'll be back in a moment. So I've now taken the module out of the small air freshener, and it's got the battery contacts going directly onto the circuit board. This little chip on board auxiliary board. There's the light sensor with its tunnel, and there's the LED, both combined into the one sort of assembly. I've disconnected the motor, I've just cut the connections off. This uses an H-bridge, by the way. It can drive the motor in both directions. I don't think this one does use that. I think this one just drives in one direction, which means it's a lot cheaper and simpler to make. And I'm thinking I may end up using this one and just end up putting the circuitry in this space in front of the batteries, because the other ones are designed such that they're fairly well stuffed. You know, there's not a lot of extra space in them, that it doesn't have a mechanism going into it. And also they've got the hinge up covers that if, for instance, I wanted to use this one, if I mounted the circuitry on here, I would actually have been better mounting the circuitry in here and run the cables, but that would involve running cables along, trying to jump onto this and run them up the back, and it just gets a bit messy. And if I mounted the circuit board on here, it doesn't leave an awful lot of space and it's closed. And it would also involve trying to align holes up in the front of this. And I quite like the idea of the little port here and the LED protruding through the front of this case. So what I'm going to do, I'll put this one out of the way. I'm going to remove the module out of this, and I'm going to mount this module in there so the LED and the port protrude through, and it's probably just sort of glue it in place and then just run loads of wires into the original motor and the battery contacts. This module here, I'm going to have to keep part of the circuit board in it because the battery contacts are actually mounted directly onto the circuit board. How does this come out? Let's use force. Oop. Is this going to come out? Ooh. It's got this strange arrangement here that it looks like the pulleys have actually, they form part of the latch mechanism, the shafts of the pulleys. It looks like they may actually be sliding down little ramps and then clicking into position here. I'll find out if I rock this back. There we go, it is. So this comes out like this. There's a little connector onto the PCB. Well, the whole thing's out now. Oh, and all the wheels are off. Yeah, look at that. The latching mechanism involves this little ramp here and then a hole for the shaft, so that when you push that in, the shaft pushes the plastic apart and then it clicks into that hole. It's very, very ingenious. It's quite a smart design. So I'm going to keep part of the circuit board. I'm going to actually cut the track, so I just get the battery contacts here and I'm going to solder directly onto the back of them. But the rest of this circuitry will not be in use, although it will still be inside the unit. I'm going to disconnect the motor here, and I'm going to, is that a connector? Oh, I'm not sure. That might actually just be a solder-on latching mechanism. That's odd. But I'm going to connect a couple of wires onto the motor, connect a couple of wires onto the battery connections, and I'm not sure if I'm going to... I don't think this one has an extra button for the manual control, but it's not needed. I'm going to mount this in here, so I'm going to do that right now. I'll be back in a moment. Measure the diameter of the light sensor, which is approximately 5 millimeters. 5mm drill. This is where I chew the plastic up completely. One of the problems with drilling plastic is sometimes the drill snatches. Let's give it a go. What's the worst could happen? Excellent. So I'm going to clean those holes off by just using a larger drill just to sort of just take the edge off them. Let's see if that fits. Will it fit? Will it fit? Or am I going to have to reamer that out just a little bit? It's not bad. I think I'm going to have to nudge the diameter for the... No, the LED is actually fitting, but I may have to nudge the diameter of this one. I may take that up to I could actually I could cheat. I could reamer it out slightly, the drill. Yeah. That should do it. How's this going to look? How's this going to look? Okay, that's looking pretty good. Right. So now I'm going to desolder these connections in the back by throwing some fresh solder onto them and popping them off. Fresh solder on. These are quite big, so they could be troublesome to get off. Maybe not. We'll find out when I try taking them off. They're also wedged in. They're springy contact. So they may ping out and splatter molten solder everywhere. Always exciting. Oh, that's very irksome. Yeah, that's quite hard to get out. Oh, it's kind of hooked through, that's why. Oh, that's extra annoying. And that's through a separate hole. Okay, that's one out. Let's see if I get any better with the second one. No, it's just as bad. Oh, that is very irksome. Yeah, they're out now. Okay, so that's now ready for me to just start patching wires into the original mechanism, which fell to bits when I took that out. It's worth noting, if you ever take one of these to bits, it goes together in this order, and if you get it wrong, it just doesn't work. So one of the bigger wheels, the smaller of the bigger wheel, goes with the, there must be a name for that, an auxiliary cog attached to the same wheel, but it goes with the large side of the wheel down. And then this one goes on here, so it mates with this inner cog, and then the outer cog, then this goes on that same shaft, and it couples to this arm so that it winds it up and down. Now, I'm just going to pause momentarily while I start soldering wires. I'll be back in a moment. I've isolated the battery contacts and the rest of the circuitry in this board. I've run a couple of wires out. I've connected a couple of wires to the motor onto this circuit board. Now I'm just going to solder the positive onto the positive battery terminal, which I've pre-tinned the wire and pre-tinned the pad with nice fresh lead-based solder. So let's get that connection on. And that leaves the negative connection. Now, I don't know the connection, the polarity for the motor yet. I'll have to actually check that and see which way the motor actually runs, what direction. The only way to find that out is to actually try it and see if the motor runs in the right direction. If it doesn't run the right direction, swap the polarity. So this module is going to be roughly about here. So I'm going to run the wires in the back here. This is time now to pop this module back in. So the small wheel goes down there. Big wheel goes there. The little doodah, the bit that actually plungers the aroma, goes on here. Is that right? Yep, that's looking pretty good. So I'm going to put this back in now. The right way round even. Oh, have I got that the right way? Yes, I have got the right way up. And that should then hold the circuit board with battery contacts in position. It might not fit. There's only one way to find out, and that's to try it. This is quite a footery thing to align. Oh, looking good. And that just leaves these wires to reconnect to the motor. So I'm going to keep them both the same length because there's room. And I'm going to make a wild guess. The motor did have a red and black wire connected to it. So I've labelled one of these orange wires. I made them both wires orange just because I wasn't sure the polarity. But I've labelled one with a little black dot to indicate what's marked negative on this circuit board, because I guess there is some standardisation in the motor industry for direction of DC motors. Although having said that, the motor might run a different direction deliberately in the other unit, so even with the correct polarity, it's not guaranteed to run the right direction. So this is coming onto the back here. This one can go down here. Again, I've pre-tinned the wires there and the motor connections. And now, I think it's time to test this. And the way to test it, what should happen is that, oh, I like the way when you turn it, the motor, the LED lit. I'm going to put some batteries into this. And after a short time delay, that plunger should wind down and then it should wind back up again. If it doesn't do that, then I've got the polarity wrong, I'll have to swap it. So let's pop this in. Either that or I'll just do something awful when I put these in. We shall find out. Something just went pop, so I think I may have got a polarity wrong. That's not very good. Did that really just do that? Yeah, I'm getting a sort of electronic-y smell. That's not good. The polarity's right. Oh, maybe it's something still connected in that. Nothing? No, it's dead. Oh, what a fucking disaster. Uh-oh. Somebody fucked up. Can you guess who it was? That's right. It was Big Clive. Bad Bear. While soldering the connections onto here, I just completely messed it up. I got the polarity of these contacts wrong, which of course smoked this module. But fortunately, I had another complete air freshener, so I now have a replacement module. That's largely due to the fact that Glade, I think it's Glade that makes these ones, they sell these units really cheaply, hoping to make lots of cash off the refills, much like the printer market. So let's solder this in, and well, I've swapped the polarity already there, so this should be right now. There's still plenty of time for me to blow it up. I can kill two of them, you know. And that would be an even longer video, because then I'd have to go and buy another air freshener. But that's not going to happen. It's going to work perfectly this time. I'm pretty sure it's going to work perfectly this time. So let's get these wires back in. These are the motor drive wires, and they go in here. Where's my solder? Where's my solder? Not the first time I've screwed up, and not the last time either. It's so easy. I could have double checked. I didn't. I was so cocky that I just thought, oh, that's absolutely perfect. Yes, that's fine. No need to check that, because obviously I've done it right. Much worse when you do it with industrial equipment. Really expensive industrial equipment. I did get the polarity wrong on something really incredibly expensive once. And the circuit board went bang, and I just put it back in the box and said this one was faulty. That's what you have to do. Yeah. So let's get some fresh solder on there. The moral of the story is, cover your ass. Always have an excuse. So on goes the negative connection to the negative terminal here. Maybe I'll even check it this time. I got these ones right. It was the other side I got wrong. Yep, that's correct. Having said that, I have taken wires off before and swapped them across, and somehow, in the process of swapping them across, swapped them again and got the polarity wrong. So let's double check with a meter, shall we? Continuity. And we're looking for continuity from the negative here to there. Yeah, that's better. That's better. It won't go pop this time and let out a little wisp of sadness. So let's now I have to rebuild this bit again. That's all right. I'm getting very good at rebuilding this. That goes in there. I could get a job at the factory now. I've done it so many times. Ta-da! Perfect. Right. Let's ram this in. No, it's all falling to bits. Cogwheels. There's nothing quite... Well, actually, there's lots of things worse than opening a gearbox or something and all the little wheels just fall out it. MD, who does technical stuff, will know what that's like because they've done it before. It just happens from time to time. So this should just click in now. There it goes. And this time, let's dress these wires round. So what I'm looking for is, if it happens this time, if it's not going to make a pop and emit little sad bursts of smoke, what should happen this time is that after a little time delay, the LED in the front should flash, that plunger should come down, then go back up again. If it doesn't, oh, the yellow LED's lit, that's a good sign. It's going the right direction. Perfect. That's ideal. Excellent. Righty-ho. So I'm going to take the batteries back out of that. I'm going to just tuck those wires around there. Line this up roughly where it's going to be going, and then try and put this back in. It's looking good. Duck those little wires down, try and line that up and shove it in. Friction fit, nice friction fit. Perfect. Excellent. So let's put some screws into this. This is a couple of these deep holes that my ordinary screwdriver doesn't fit, so I'm going to have to use a random other driver. Rather annoyingly, my usual sort of high spec, high voltage type screwdrivers, they don't go down either because they've got the insulating sleeve. Quite often I'll end up just taking a pair of snips and just nibbling around that and lengthening the exposed bit, but that's the point at which it suddenly becomes non-compliant. Right, I'll just put a couple screws in to try this, first of all, and then I'll put the other ones in after, because all it needs at the moment is the two. So let's get a can of air freshener, which I don't have. One moment. Here we go. And I'll shove it in. Is that the right way around? There we go. Stick the batteries in the right way around, since it obviously does not have polarity protection. Is it going to spray? Is it going to spray? Yes, it is. Excellent. Perfect. And now it's going through usual routine, and after it's done a couple of sprays initially, the only time it will spray is when it detects with this light sensor a little modulation in the room. So, successful project, said Clive, meaning successful as in, I kind of screwed it up. Dead circuit board. Oh, not to worry. These things happen.